Hi friends, it's Miss Beck. We have been learning to calculate volume of prisms in math. Volume is the three-dimensional space an object occupies. So what you heard was three-dimensional. In a lesson last week, I explained that 3 dimensions is the same as saying 3 measurements. So in order to calculate the volume of a prism or a figure, you must measure 3 parts of that object. In our case, we are trying to find the volume of prisms. Don't forget, a prism is a figure that has 2 congruent bases. When I say congruent, I mean that they are exactly alike. Those bases are connected by faces. So if you have a rectangular prism, clearly there will be 4 faces on that prism which connect the 2 bases. If you have a triangular prism, then your congruent bases will be connected by 3 faces, and so on. Those faces do not have to be all congruent. So today we're going to rewind back to 4th grade and talk about composite figures. Now you might be asking, why are we talking about composite figures again? The reason is, if you recall, a composite figure is a figure that is made up of several other figures. Here's an example. So this is a figure, it's a polygon. A polygon, don't forget, is a figure that has all lines that are straight and the figure has no openings. It's a closed figure with straight lines. Okay, so it's really hard to calculate area of this figure as it is. So what you want to do is create 2 or 3 figures, depending on what the figure looks like, that are squares and rectangles, so that you are able to calculate the area of this figure. In this case, I would like to bisect it by putting a line right here. Then I've created a square, and then the bigger figure, which is a rectangle. Now, how do I know that this is a square? I know that this is a square because this side is 3 yards wide. And this side here, if I go up and look at the arrows that are the same length as this line is 3 yards also. So I can multiply 3 times 3 and get the area of this square right here. Then I need to go up here, and I see that the length of this line is 8 yards, and the length of this line here is 12 yards. Well, 12 times 8 is 96. So this rectangle, the bigger figure, has an area of 96, and this square has an area of 9 yards. If you put the 96 yards and the 9 yards together, you get 105 yards. The area of this composite figure is 105 yards squared. One more composite figure. As you can see, it's in the shape of an L, and it gives you this full length of 16 meters here and this full length of 9 meters here. Now you have a choice. You could either bisect this figure right here and make this rectangle. That would be 9 meters by 4 meters. And have this rectangle over here, which we're not sure, we'll figure out this side, but it has one length of 3 meters here. Now, if this whole length is 16, and we know that part of it is 4, don't forget this whole thing is 16. So if the whole is 16 and part of it is 4, we subtract that and know that this length is 12. So hence this line here is 12 and this is 3. So 12 times 3 would be 36, and 9 times 4 is 36. So 36 plus 36 is 72, and you have an area of this composite figure of 72 meters squared. You can also bisect this figure right here. If you do, then you would have to measure this length here, the shorter length, times this length here, 4 meters. Now, we know that this entire length is 9, and part of it is 3. So we subtract that 3 from the 9, and we now know that this length is 6 times 4 is 24. So the area of this rectangle is 24. 6 times 4 is 24. Then we have this long rectangle here, which is 16 long times 3 meters high. So when we multiply 16 times 3, we get 48. And then when we add it to our 24, again, we get an area of 72 meters square. We're going to practice some of these today because for the next 4 days, Tuesday through Friday, we're going to learn how to do this with figures that are 3-dimensional. So this is a good warm-up to go back to 4th grade and refresh on how to find the area of composite figures so that we can move forward and find the volume of composite figures. Have fun, everyone. Enjoy.